myself, to be honest. But yeah, for the first 2 minutes, pretty much all you need to do. I'll share my screen. Is I put the link in the chat for the challenge code that we're going to be using. You just copy that, put it into your browser. I copied that wrong. Copy text. Okay, I'll try that again. You can just hit download here and get it into your somewhere in your computer. I'll give people a few minutes to do that, and then I will get started. I will say a few things. This is primarily based for like beginners trying to do maybe their first web hacking challenge, whether it's for a CTF, whether it's for bug bounty, or you're trying to learn more about application and network pen or application and web pen testing. Once you download the code, you can just run python3 website.py, and this will host the website on your local machine. You can go to your web browser of choice, go to localhost, and we can see the web page right here. Anybody having any issues getting this downloaded and ran, please let us know in the chat. Yes, this is going to be recorded. Is there no way for like from my end to disable the elevator music? No more music on your end. That's good. Okay, I'm going to assume everybody has had the chance to get this downloaded and running. If you're having any issues, please let us know in the chat and we will get you all figured out. So I'm going to teach you guys how I would tackle this with me not like knowing how to do much. Like if I see something like I'm gonna go in, I'm gonna like actually research like how I would do this if I didn't know like what technologies or what I was attacking. So in this case, it looks like we just have a login page. The first thing you can do is inspect it. Wait for this to load and see if we can find anything interesting. Some CTF challenges, you can potentially find hard-coded credentials in the HTML. But it looks like here there is nothing particularly special just besides normal HTML. Next, we could go to the storage, and this is currently there's no cookies right now, but right, what we can do first is we have registration functionality. So I'm going to go and register an account. But before I do that, the first thing that you probably want to do is check if this is like a known software, there's potentially like default credentials. And you could Google for those. So if this was like actual like real thing, you could look up like secure corp default credentials on Google, and it would give you some credentials that you could try. The next thing that I like to do is see if there's like any like basic like admin or admin password, just to try a few things like that. That's not going to really help here, but that's some low-hanging fruit that could potentially give you a win. The next thing that you could do is run a directory bust to find hidden endpoints. However, in this case, we do not need to do that because everything that we need will be visible on the page. So I'm going to try to register an account because I'm unable to log in. I'm going to create an account with the username Jake and the password Jake. Now that we're registered, I'm going to log into my account. So it looks like we have a user dashboard here. It says welcome Jake. So first thing to something to note here is that our username is being reflected back to us. Whenever you insert something into either a login page or some sort of input that you control as an attacker, you want to really watch like where you enter your inputs, see how it travels, and see where it ends up. Like in this case, we registered the name Jake, and it ended up on this user dashboard page. So that's something to keep in mind for later. But as we look, see here, there's a news, a tasks page. There's nothing much going on here. We can inspect, check out the HTML code again, see if there's something interesting, maybe hard-coded credentials or other information that can help us. Looks like there's nothing too special here. So we now can look at cookies. We did just log in, so we should be given a cookie. And it looks like we have two different cookies here, a session cookie and a permissions cookie. Now, a lot of web challenges can be completed by exploiting a session cookie. And if I'm tackling this as if I didn't know anything and I'm trying to learn, we know that the website is being run Flask. So what we can do is look up like Flask session cookies and then like exploit or something. We can Google this and we can start reading these articles and we can start learning more about the technology that's underlying. Pretty much what's happening here is whenever we create an account, a cookie is set, and now we have access to it here. So I'm going to copy this because once you research some more, you'll discover that this is all, I believe, this base64 coded. So I'm going to show you a tool called CyberChef. And this is an amazing tool for learning how to, or doing capture the flag, or just website hacking, or any type of security, really. I'll give that a second to load. Paste it here. Run from base64. And as we can see, we have username, Jake, and then we have a bunch of trailing garbage that doesn't really matter here. So what we know so far is that whenever we create an account, we log in and we get a cookie set, and it sets it to username and Jake. Now, if we wanted to further look at this cookie, we could look into this GitHub repo called flask unsigned. Wait for that to load. Pretty much what this does is it can run a whole bunch of different attacks on Flask cookies. Because pretty much how these cookies work is we could not just go in and change our name from Jake to admin, because if the website is doing their signing correctly, it won't work because the cookie is, I don't know if encrypted is the right word. It's signed. The cookie is signed. Like I'll show you an instance right here. We're not using JWTs, but this is the easiest way to show it. If you have, oops, wait for that to cook up. I think I need to do double quotes here. Okay. So as we can see here, this creates a JWT with our secret. And pretty much, if the website's configured correctly, you need to know this secret in order to be able to modify this cookie. Since I know I create this challenge, this isn't our attack vector. Let's move on to the permissions cookie. Can anybody here tell me I identify what is in our permissions field here? What like type of type of data is here? It is hex, but what does the hex represent? Very good, Carl. It is an MD5 hash. So basically, if we ever see an MD5 hash, we can go and try to crack it. So we can see what the plain text of the hash is. So if you look up like MD5 hash cracking, you will eventually find a website called CrackStation. CrackStation is another useful tool. It allows you, it has pre-computated like password combinations and hashes. So what you can do is paste in your hash, verify you're not a robot, and click crack hashes. So once we crack this hash, we see that it is indeed type MD5, and the result is normal. Going back to the website, we can see that the current permissions we have are set as normal. So if our goal is just to try to take over to take over the app, maybe we could try setting some different permissions. And usually the best thing you could try to do is set yourself as an administrator because usually whenever you're doing a CTF, a lot of times the privileged account with like more interesting things is either under admin or administrator or something along those lines. So let's try go back to CyberChat, create an MD5 hash, and let's try administrator first. Wait for that to bake. I'm going to copy this and I'm going to update the cookie so that it now has the administrator permissions. Whenever we refresh the page, it said your current permissions are unknown. So we guessed wrong. So maybe we can try admin. Copy that cookie. Go back to our cookies here. Paste, hit enter, and refresh the page. And now, as you can see, we now have access to the admin panel. Basically, what we were doing is the website poorly it allowed the permissions to be set on the client side. And you should never ever trust client input. It's bad because hackers can do exactly like we just did there. We just manipulated the cookie and we were able to escalate our privileges from a normal user to an administrator. I'm going to take a pause there. Any questions? All righty. Trica. I forget there's delay. All right. So in this application, there's actually two different authentication bypasses to administrator. So I'm going to go back to this page and back to the login panel. So whenever we, okay. So whenever we are logging in, we have a username and password field here. And what's happening in the actual backend of the site, let's see what happens when we try to like actually log in here. We get, this is the SQL query that is happening in the backend. And if you're not familiar, SQL is a structured query language, and it's how a website like this can interact with the database and the backend. It allows you to, like in this case, we are selecting all of the data from the users table, where the username is admin and the password is admin. So we typed in, so let's select username. Let's say this is password. As an attacker, we now know that we control this username field and we control this password field. So this is a problem because if we are able to manipulate the query in such a way, let me open code, make sure I don't leak anything. Okay. Open up a new text file quick. Okay. Oops, too much. Okay. So we control this. So what we can do as an attacker is modify our query so that instead of just typing a username, like username, Paul, we can actually close this so that it's an empty string and inject something like I guessed it, or 1 equals 1. So basically what we've done here is we're asking the database to select everything from users where the username, actually we need to put, we're going to guess that the username that we're trying to take over is admin. So we're going to put where username is admin or 1 equals 1. So what's happening here is that we need to find, we're trying to make a query where the username is admin or 1 equals 1. And 1 equals 1, this means true because 1 equals 1. So basically, you have this, which is going to return whatever it returns, and this is going to return 1 equals 1, which is true, which means that it's going to return whatever admin is here, whatever the this username. And the beautiful thing is, because we put these dashes here, is it's comments. So we don't even have to worry about the password part because the SQL query ends right here. I'm gonna pull this up and oh boy. Dev SQLite viewer. Yeah, okay, here we go. I'm gonna open up the database. You guys don't have to do this. I'm just doing it for demonstration purposes. How do I just browse data? Okay, here we go. So here's what our current database looks like right now. So as you can see, we have an admin user with a password that's very long and the admin permission. Another user that's just normal, and the user account that we created with username Jake. I don't have any audio options. I don't have any audio options except to unmute. I think you have to hit your settings wrench and go to sound and settings. I'll let someone else help you. Yeah, so I want to show what these SQL queries look like. So if we go back here and well, I'll copy this. Quick. Here we go. Let's just run this query and see what happens. 0 rows are returned because there is no username, the name user, and a password. But what happens when we try admin, the account we're going to take over, and password? This is just the equivalent of entering admin and password into the login field. Why am I getting syntax errors? These need to be double quotes. They get to use double quotes with SQL syntax. My bad. Okay. That worked. Wait. I had to return a user. That's bizarre. But anyways, so what we could do with our query is pose it here, or 1 equals 1. And when we run it, all of our usernames and passwords get returned here. And by default, I believe it's just going to take this first admin user, and that's going to authenticate us as the admin user. So if we go into the username field and type admin, and then we're typing admin, we're closing this string, or 1 equals 1, and hit login, we're able to log in as the administrator. This is a very, very, very basic example of SQL injection. Okay, now it's a good question. So if a website developer has properly done their SQL queries, you can do input sanitization, but the best thing you can do is called SQL parameterization. I'll wait for this. So pretty much this, if you use parameterized queries like this, and for this particular language, instead of just passing the username, you use a colon and username parameter, it will not allow you to do SQL injection because yeah. I don't even know what language it is. Anyways, so that was a very, very basic SQL injection demonstration. Any questions so far? The next part, we're going to want to use a tool called Burp Suite. Burp Suite is sort of acts as proxy between the browser and the server. And I'll describe what we mean here. You can just hit start past all this. And if you're not using Kali, you can just go to Google, just look Google Burp Suite. Go to their website and download it. Close this. Okay, Burp Suite is open. I'm going to close this and go to our proxy tab. Here we can open our browser. And by opening our browser through here, all of our web requests are going to be made and sent through Burp Suite. So we have to re-exploit real quick. Do admin one. Okay, so now we're back here. And we're back at our admin page. We have the options to run a device health check, see the executed command, and see the output. So whenever I'm just gonna mess around, see what stuff gets run, see that host name gets sent, and there's this user input tab. That's interesting. So we'll keep that in mind for later. We'll forward this. And it prints the host name of my actual machine. So this should be setting off alarm bells as a web pen tester because this application is running commands directly from the host system. Because if I were to run this, it's the exact same. So we know that we have command execution here. However, look at host name, look at who am I, run that, see what happens. also Yoda. And then we have the ping command here. And more interestingly, we now have user input. So if we just want to check, like use it how it's meant to be used, hit run, see that we're sending ping as our base command and localhost as our user input. I'm going to forward that. Oops. And we can see that it's successfully running ping. So as an attacker, you want to think, how can I control the command that is entering the system? So I'm going to rerun. I think this is what I want. I want you guys to take a look here. And ping host run. Okay, here's our request. If you hit Control R, it'll send this request to your repeater. That way we can just play with the request, hit send, and it's really, really easy. So at this point, I'm curious to what you guys would try and do here in order to take over the underlying operating system of this application. Any ideas in the chat? Thank you, Shiloh. Very nice. Okay, getting a lot of good ideas here. And you guys seem to be on the right track. However, there is one thing that we could do, and if it works, it would be way simpler. Instead of how you do OS command injection, what if we could just run our own command here? Instead of having to just do like something like this and then run our command, we can make this a lot simpler ourselves and just do who am I? Or sorry, do like I don't know. What's the command that we could run? ls. And then our user input could be -la. We hit send. We can hit render. So instead of looking at this HTML code, we can see what the web page actually would look like. And we get an error. And it says only ping, who am I, and hostname are allowed to be ran. So we need to go back to ping because we were allowed to use user input. And we could use, there's several things that I saw. You can do a semicolon. You can do ampersands. And the reason I want to show you how this works. So right now, this is what the ping request would look like. Wait for that to load. And it's pinging localhost. The executed command is ping-c for localhost. And this just means send only 4 ping packets so that this doesn't run forever. So what we need to do is modify the input so that when we do ping-c4, this semicolon means, hey, run this command, and then after this command is run, I want you to run who am I, or something more malicious, like echo, who knows. And if we run this, we can see that first it runs our local host, or our ping to localhost, then afterwards it echoes hack. So we can try this from here, from Burp Suite. Ping localhost, put a semicolon to close off that command, and then run the next command, say echo hit send. And as we can see, we successfully have gained command execution on the system. So now there are several ways or several things we could do. If this is a capture a flag competition, perhaps there's a flag we need to capture. So you could do something like cat flag.txt, but I did not create a flag for this. So what we're going to do instead is try and run a reverse shell. A reverse shell pretty much allows you to, uh, whenever you run a reverse shell from the attacking system, it creates a connection back to our machine, and it allows us to run commands, whatever command we want, on the remote machine. So my favorite website for generating reverse shells, web shells, Google web shells, revshells.com. This is a really great website. So I'm going to click on that, wait for it to load. Sorry, it's so slow. And you need to realize what you need to know what type of operating system that your machine, the target machine, is running. In this case, we know that it's Linux because I ran it on my own system. But say we didn't know what type of system it was being run on. One thing you can do to discover very quickly with like I would say 99% accuracy of what operating system that the host is using is simply pinging the host. And as we can see here, the time to live is 64. Now, if I were to go and try to ping my local machine, which is a Windows machine, I think they can talk to each other. I'll try. This is a Windows machine. Like here's my this is from my actual host computer. And as you can see, 192.168.55.205. We ping that, and the time to live is 128. So typically, almost 98, 99% of the time, a Windows machine will have a time to live of 128, and a Linux machine will have a time to live of 64. However, if you want to be more sure, you can also run nmap against the IP address or the name of the machine. In this case, you can do -O, I believe. And this will go in and do some extra scans and try to figure out what type of operating system we're using. And as we can see here, it's Linux in this case. So we can go back to here. And this is the most simple one. We can just type in our IP here. In this case, it's localhost. But if you're doing this on a remote machine, it would be an IP address like 192.168, or actually, depending upon if you're like connected to a VPN or if you're attacking a machine on the internet, it could be like 10.251.125. Yeah, just any IP address. We're going to go to localhost because I'm hosting this locally. And then you can pick any port really. And a CTF challenge, it probably doesn't matter too much what port you use. However, if you are doing a real life assessment, you're trying to be stealthy and not get caught, you may want to consider using a port that is not that is commonly used, so that if blue teamers are coming in and looking at port traffic, they don't see port 1337 and immediately get tipped off that, oh hey, I'm getting hacked. But if I do something like port like 443, like HTTPSs, it seems a lot more. There's a lot more. It's a lot more likely that you have port 443 flowing through your network as legitimate traffic. That's what I'm trying to say. But since we're doing a CTF, we can do whatever port we want. In this case, I'm going to use 1337. We can set up our netcat listeners, copy that. And this pretty much sets up our computer, and it's waiting for the destination computer to come and connect back to us with a reverse shell. Now that this is waiting, we can take our payload that we generated, copy it. That's the real port hackers use. Real. Where is it at? Okay. Go back to Burp Suite. And we're going to inject this into our payload. Now we hit send. And it says BNSH syntax error, end of file unexpected. So something we need to be careful about Actually, does anybody see the problem here? Why this maybe didn't work? Right on, guys. It needs to be URL encoded. Basically, you notice here how our first parameter base command equals ping. Then we have this ampersand sign. And we notice we have this equal sign. And that if we had like an equal sign here, it'll break our stuff entirely. So there's some characters that are not safe to use as user input in a URL. So we can go back to our handy friend, CyberChef. Wait for that to load. Paste that. And now we can do our URL encode. Search URL encode recipe. And we also want to encode all special characters because it's this ampersand that's giving us the issue. So now we can copy this. We can enter our newly encoded shell and see if we have better luck this time. Okay, we can see if we got a shell, and it appears that we did not. Popping shells could kind of take a few minutes. You just need to see what, like what payload works on what systems. It just takes a little bit of messing around. So we can go back here and try maybe using bash instead. I'm going to copy this, re-URL encode it. And a lot of hacking is just it's never going to be, you're never going to be right the first time. Perfectly okay. It's just all about experimenting. Let's see what works. Try this. Hit send. Okay, that also didn't give us anything. Let's try a different payload. You can scroll through here. And one of the easiest ways to get a shell is with netcat. So first we would need to see if we have netcat on the system. And by to see if we a binary exists on the system, we can use which and then netcat. As we can see, we have user bin netcat. So what we can do is simply netcat into our IP address, which is localhost, and the port that we specified earlier. We can hit send. Ping command timed out. That looks promising. And now we can see that we have a listener here. However, it breaks. Does anybody know why it breaks? And why we don't get a shell, only a connection, not a full shell? What do I need to change about that netcat command in order to spawn a reverse shell instead of just creating a connection back on that port? Any ideas? Yep, -E. So now we can do -E /bin /bash. And this will pretty much tells you, hey, once I create this connection onto port 1337, I want you to run the command /bin/bash. E is for an easy win. Yes, that's right. We need to restart our netcat listener. Run this. And notice that, okay. And now we officially got connection back. We type in a command for Yoda, type ls. We can now see the website.py, the challenge DB. So there's a flag here. You could read the flag. You can read the challenge DB. And see, oh, hey, now you have access to the user and admin's passwords. And yeah, that's pretty much. You did this hack yourself, technically. Correct. But we now have two options of what we could do. And I'm going to make a quick poll real quick. Either one, I can open it up for a Q&A, or two, we can learn how to automate this attack completely with Python. So I'll teach you how to use the Python requests library to actually go in and use code to send these requests. So you could write an exploit, just hit enter and run it, and it would automate the full exploitation chain. I'm going to create a poll. Is it possible to do this in Discord? Poll. Oh yeah, there we go. Topic, questions and answers for automate the attack. Automate. Okay, if you guys want to vote in that poll real quick so I can see what you guys want. All right, we want to do, seems, want to automate the attack of Python. Very good. And we should have time for like a few questions at the end anyways, so it should be fine. Name it exploit.py. Save it in the same folder. Save. Okay. There's many different ways you can automate attack with code. You can use Python, Ruby, you can use Perl, you can use Python request, you can use the Python HTTP library, blah, 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 blah. In this demonstration, I'm going to use the Python requests library. It seems to be the most popular, and rightfully so, because I think it's great. Wow, I can't type today, guys. Okay. Oh, hi, Chrissy. I'm going to exit this reverse shell clear. And if you try to run this and it says request isn't installed, just run pip install requests on your machine. You get something like this. You could run pip install requests again, -test break system packages. I would encourage you to use a virtual environment, but I'm too lazy to do it myself. So now what we need to do is automate the exploit. And in this case, I'm going to automate the SQL injection or use pipx. That's probably the best way to do is to use pipx. Okay, so we're going to take it from the top as if we haven't hacked this yet. So the first attack is a SQL injection. So I'm going to put this back in Burp Suite actually, because it's really helpful to see this in Burp Suite. I'm going to drop all these packets because they don't matter anymore. Go to localhost. I'm going to turn off intercept for a second. And I want to first create or attempt to log in with this SQL injection vulnerability. So I'm going to hit login. Before I do that, I'm going to intercept, hit login, and we can see we make a post request to slash, and none of these cookies particularly matter because we're unauthenticated, but they just didn't clear themselves because this is a badly made website. Yeah, so the main important things for making a request with Python what type of request, whether it's a get, a post, a put, the URL that's going to, and the data that's being sent. So we could go back here to our exploit, set our URL equal, in this case, HTTP localhost 480, that. And now we can make our request. And the reason why I do this is because we're going to reference localhost several times. So I just put it in a variable so that we don't have to type localhost every time. So now we can set a variable called r equal to requests dot post, because it was a post request. The first parameter is the URL that we're trying to visit. I'm going to use a Python f string here, enter my URL, and we're making the post request to slash. So actually, in this case, we don't need a f string. We just put URL. Next, we need to insert our data. So we can create a data variable called data. And whatever you use requests, you use a Python dictionary. So let's go back here and let's copy this real quick. I like to just copy my payload here and like put it in a comment. That's easier. So I don't have to keep going back and forth. So the first parameter is user name. And the payload that goes into there, we can just copy this because it's already URL encoded for us, which is very convenient. Put this here. And then we use a comma to dictate the next field. Password is equal to this blank. There's also something helpful you can use if you want to, if you're doing more complex exploits and you need to like debug what's happening, you could set proxies. But first, we need to set our data here. Data is equal to data. This is putting this data into the URL. But I'm going to do setup for proxies. This isn't too important for you guys to know right now. I just want to be able to show you. Yeah, can't type. So this is going to send our requests to Burp Suite and then to the website. We also need to specify our proxies equals proxies. Well, what this will make happen is we run this by running Python exploit.py. Make sure I'm in the right directory. And as we can see, our request is being made. If we want to repeat that and see if it actually works, you hit Control R, right click, and send to repeater. Hit send. You get a 200 OK. Let's see if it actually worked. Okay, we got a error, invalid username or password. I'm going to try. Okay, it seems like it didn't. We didn't need URL coding, so I'm going to go back here. You just type admin, and because we're using single quotes to detonate our string, we need to use a backslash to escape this, or 1 equals 1. 1 equals 1. We'll try this again. Drop that. Run our attack. See if this works. I'm going to send it to repeater again. Control R. Hit send. Okay, we get a syntax error. I think it's because it needs a. Oh wait, we have one too many quotes. Okay, let's go back here. Troubleshoot our payload. I'm gonna let. What do you guys think is wrong? What do you think we need to do here to fix this? Crowd involvement. Woo. One extra equals sign. Okay, very good. 1 equals 1, dash dash. We'll try this again. Hit Control C to close this. Go to proxy, drop this, and we will rerun our exploit. Go back here, rerun. Set us to repeater again, hit send, and it says 302 sound. This looks like our authentication worked. We can follow this because this means that it's redirecting you to a different page to /user. Follow redirection. And as we can see, it didn't forward us to the right place for some reason. But we now know that it seems that we were able to log in successfully. And in order to verify that, we can do our oh, I need to do a session here. Oops. Okay. Another thing about requests is we could take the cookie from this request that gets set. Yeah, see here, notice that the permissions cookie and our session cookie gets set, which means that we were able to log in successfully. What we could do is we could parse out this cookie. I'll put my payload in the chat real quick. Okay. So, okay, I'll explain that again. So, this out bottom. Yeah, you don't need space after the admin. It's just potato. So as we can see, we were like set our variable like this. And if we don't escape this apostrophe, it's going to assume that this is our full string. And the rest of this, it's just going to cause a syntax error. So in order to make this, make Python not think that this is the closing of the string, you use a backslash to escape it so that it goes to this, and this is our full string instead of our string terminating early right here. Does that make sense? And yes, we could also use double quotes. That's another perfectly viable option. It's really just your preference. We could do that. Why? What's that happen? Go back here. And this would also work just as well. So, like I was talking about earlier, we could go in, we could take this request, take out the cookie, and send it manually with our requests for the rest of the attack. However, that isn't necessary because of requests.sessions. Requests. I forget. So basically what this does is that anytime we could use s.post instead of request.post. And all of these requests, whenever you use this session, it will be as if you went in, you logged into the browser, you got your cookie set, and you can keep on using that cookie for the rest of your requests instead of having to manually set it. I'll pull up the docs real quick. You might be able to describe it better than I did. Last sessions. Yeah, it allows you to persist certain parameters across requests. I would say that's probably the best way to describe it. As you can see, we set request.session, and we will continue onwards like that. Okay, so now basically we're creating our first request, and this is us logging in. So this is the first attack. We did our SQL injection, we bypassed the login, and now we're able to log in as the administrative user. So at this point, we know that once we log in as the administrative user, make sure this is off real quick. Drop, intercept. and re-inject in. I keep on fat fingering this. Users who create green winners. Okay, sorry, I was fat fingering my attack. So we know that our next attack, whenever I'll turn on burp again, and we're running our attack with ping. Doesn't matter right now. It's a post request to /admin, and we have our base command and user input. I'll let you guys try to create the request that we're going to need in order to do this and put it in the chat. See what you guys can come up with. Yeah, you probably could, Chrissy, but I'm just doing a very basic entry level demonstration, so we're not going to get into anything too crazy with SQL. Has anybody been able to crack the request yet that we need in order to pop a shell? Oh, yeah, you came late. Yes, if you try to change this to something besides ping, like you do, or I don't know, how about ID? Yeah. Run that, render, and it says only ping who am I and host name are allowed to run. So you pretty much just do command injection, but I think you came late or something. Still waiting on to see if anybody who will blood the challenge completely automated. I guess why wait for y'all? I can do this in my end as well. Back to here. Our next request. Please don't run that, guys. The command that Chrissy just ran, you will destroy your computer. Potentially. I'm gonna continue on. You guys can keep trying on your own, or you can watch. I'm gonna make another request. It goes S that post or to a URL for the /admin endpoint. Our data we can get from here. Set up our dictionary again. Base command needs to be ping. That's one of the allowed ones. Okay, like just that one person. Our base command is ping, comma, and then our user input is our reverse shell. So we can finish the ping with like localhost. Our semicolon that we talked about earlier. Oh, you don't even be able to hear me this whole time. Oh no. I'm guessing other people can hear me. But localhost, we close this command and we run our next command. And I believe last time we used netcat, localhost, our port, and then we use -e because we want /bin/bash to be ran right when we get connected. SoCat, yeah, Chrissy, SoCat's great, but the syntax is kind of complicated. And I was trying to keep it simple. So now we can go back here. We can set up our listener. And you can also set this listener within this code, but it's a little complicated because you have to open a new thread, and there's no need to do that today. So let's try data, set data equal to data. And we can also set our proxies again to troubleshoot if it's not working. And now we're going to also, yeah, we don't need output because we'll just see if we pop the shell or not. Here on our exploit, I think I had old stuff. Second, I'm trying to pop the shell. Okay. So our first request is doing our SQL injection. We forward that, makes a request to, it does the redirect to /user. So I just hit forward, and our request to /admin has no data in it. But our data is right there. That's bizarre. Okay, here's our data. As we can see, our basic command ping localhost, and this is our semicolon, and then our reverse shell. Oh, is this better? I have my mic on a bad setting. Here, I'll put this closer to my mouth. Is this better? Okay. Forward this and cross our fingers, and we have a reverse shell. So I will copy this code out to you guys so you can put it into your notes. Sorry the quality was bad before. I'll be sure to have my mic in front of my mouth. That is our final exploit code. And now you learned how to do a basic SQL injection, how to do OS command injection, and cookie manipulation. And you also learn how to automate all of it with Python, which is an extremely, extremely valuable skill because sometimes exploits, some of them you just can't do by hand, or else it would take way too long and you need code to help you automate your attacks. So if you're going to learn how to do web exploitation, learning how to use requests is an extremely, extremely valuable endeavor. And I will also lead you with a resource for learning a request. Uh, This is a great repository that I used while studying for and passing my OSWE, and it teaches you how to use a whole bunch of different stuff. If you want to read further, I will copy this over to you. Okay, there's that. And yeah, that's all I have for tonight, guys. Any questions that you would like answered? Whether it's about CTFs in general, whether it's about this particular exploit we did, feel free to fire. And I'll have like next 5 or 10 minutes if anybody wants any questions answered. And this one was pretty introductory. I want to do a more like intermediate to advanced level one next time, where we'll actually have source code and we'll get to really dig into some source code and see, oh, these are certain coding mistakes that programmers use, and we can figure out how to exploit those. For my OSWE exploits, did your scripts have to also catch the reverse shell? So for the exam, you can catch it on a different shell, but I personally did it within my script, and I gotta find where my code was. Oh yeah, it's in the offsite Discord. Okay, I'll find it for you real quick. Give me a moment and I'll find the code. It's a little far back. Okay, here we go. Okay, I'm gonna paste this into the chat. So basically, what this code does, if you want to put it into your uh, notes, it starts a listener, but it starts it on a different thread. Because if you don't start the listener on a different thread, you can't open a listener and run an exploit at the same time on one thread. It's not possible. So you have to start another thread, open your listener, and then it allows the code to continue to run. Is it good to use HTTP port for netcat? If you're talking about like being evasive and stealthy, HTTP maybe isn't bad, but like you kind of have to look at what ports are open on that machine and what like would make sense in like an enterprise environment. Like people will do it over like port 53 because there's always DNS, or like port 443 because it's HTTPS. Let me scroll back up. Okay. Where do you go to practice more advanced web CTFs? Why do you think? What do I think of Hack the Box challenges? Hack the Box definitely has some pretty good web CTFs. I think in terms of like learning web, I think Portswigger Labs is excellent. I'll pull them up real quick. And if you go here, and these labs vary from, I think, I've never done the crazy hard ones, but they can be stuff from like easy to like expert level. So this is a really, really, really good place to learn web security. And if you want to learn do more web CTFs, you can go to ctftime.org and you can look up at the upcoming CTFs. And I look for whatever has the highest weight. Like this will be a pretty challenging CTF. We're doing this, I believe. Actually, I don't think we're doing this. But you can go here. Like this one's going to have some insane web challenges if you want a really, really big challenge. But yeah, just look through CTF time. Find CTFs that have high ratings and go and try. And also, you can go in and like read like old CTF write-ups. That's a really, really good way to learn. Do I pen test for my career? I've done some network penetration testing professionally, but all of my web experience is pretty much just been capture the flags and like studying for certificates and all that. But hopefully soon I will have a full-time job and start to do, probably will be more net and pen, but I'll probably do some web as well. Yeah, so the sleep part, if you don't run sleep, that thread you have, you're going to open your thread for netcat and you're going to run the rest of your exploit code. And once your exploit code is done running, the Python script will just stop. So you have to run sleep so that you can actually interact with your reverse shell before it just dies immediately. How long did it take for you to get your OSWE? It's a complicated question. Uh, I have somewhat of a. I didn't really do a good job tracking my OSWE data. I like started the cert in 2022, and I just wasn't good enough at web pen testing to be able to do it at that point. So I took a break, and I tried it again 2 years later. And as you can see, I was pretty inconsistent with it until this December. That's when I really started uh, amping up with it. But this isn't really a full representation of all the studying I did because I've done a lot of web hacking CTFs, and that's probably the majority of where I learned all my stuff, and it's not represented here. So I don't really have a good answer for how long it took because it was so spread out. What got me into cyber? Uh, let's see. My junior year of high school, we had the option of either staying at our high school and taking normal classes every day, or we could go to this trade school. And basically, you could go to the school and you could like learn different stuff. Like you could learn how to be a nurse, you could learn how to do cybersecurity, and I decided to do the computer stuff. The first year was computer networking. That got me really, really interested in computers. And then the next year was cybersecurity. and that just taught us like all of like the fundamentals of cybersecurity. And there, my teacher introduced me to the National Cyber League, which is a pretty big capture the flag competition for US based people. And that's what got me really, really hooked into cybersecurity is doing National Cyber League, doing those CTFs, and learning so much from that. And it's CTFs are so much fun. For the former gifted kids. Very true. Very true.